we get started, do you have any like questions regarding like what we're gonna do? Like so Daniel, you've mentioned like what like you've already asked like what is networking, and I told you it's basically just like getting computers to communicate with each other. Um, what exactly were you expecting
That.
from like a networking class? What did you think that would mean?
Um, like about how to make kind of your own mini web server so that any computer could access the files in your server. I was
So
thinking on that.
right, so we're definitely gonna do some of that. Um, though I'd say that's a bit later down the line. But yeah, so a server, like a server as an application, will use networking as a way to transmit data. And we will be having a class later on, for instance, on the HTTP protocol. We're not going to go too much into the details, but we're going to look at HTTP, how it transfers data, and also how HTTPS is secure compared to HTTP. Like HTTPS is
Literally what
extremely
the S stands
interesting.
for.
Yes, exactly. Literally what the S stands for. It's very interesting.
I
And
knew that
also,
much.
and also, if that's something you guys are interested in, I'd be cool with having a series on how to make your own home labs. So that would be, setting up, like, regardless of what your ambition is, setting up your own server, or maybe it's just like a small Raspberry Pi, or maybe like you want a fully virtualized environment with like monitoring VM and all that jazz. You want the whole shebang with like your own router. We can do like very big, very small, but but like always try to do what you guys want to do. So for instance, most home servers initially have a storage server. That's like the core of the thing. Sometimes, for instance, my home server, my home lab, I have a file server, I have a bunch of web servers, I have game servers, I have a monitoring, like I have a way to monitor all that, I have a firewall, I have a bunch of things, all of that virtualized on just one machine. I'm running all of that off of just one physical machine. So you can do a lot even with very little like physical devices. So if that's something you'd be interested in, we can definitely work on that. Although it's less networking and more like systems and like setting up services. But networking is an integral part of setting up those home labs. So this is why I feel like we absolutely have to start with stuff like IP addressing. All right, so let's get started. Today we're going to talk about IP addressing. Now, before I move to the next slide, what do you guys think about IP? Like, what is IP addressing? You've probably heard of the IP address. What is an IP address?
Well, whenever I have to talk it to like a customer, like when I'm selling computers and stuff like that, I normally say it's like, you know how your home has a home address where people know how to send you mail, things like that. Well, an IP address is basically an address of where your computer or device like is located. And basically, whenever you visit anything, it shows that your IP address has visited that location, basically connecting like one address to another in a way.
Right, right. So yes, we are going to make a lot of analogies between IP addressing and like regular, like post office style addresses. What about you, Daniel? Do you have any idea what an IP address is?
Well, I only know that it's pretty complicated to use it because what I've noticed is that my IP address indicates my relationship to to um, to another machine. So, for example, I think that there is a big machine from which all the Mexico's computers come from, and then you have a specific number, so you know that if you want to go to a computer that's in Mexico, you need to use that number, and then if you want to go to a certain part of Mexico, you have to use another number, and so on. So it's kind of uh, an address, but I think that it's more hierarchical for what I've learned.
Ah, I see. So there is a certain hierarchy in IP addressing. but you'll see it's not as clear cut as it's not. Okay, so I think you might be confusing IP addressing with domain names. What you're describing sounds more like domain names. Like
Yeah.
google.com is a domain name, right?
Okay.
Right.
Thanks.
There is definitely a link between the two. We're not going to talk about it today unless like we go for a bit further. But I hadn't planned on that. But
kind of like .gd or .ru, things like that.
Right, those are domain names. Essentially,
yeah, that's what I was thinking.
So we'll get to that when we talk about DNS, which is pretty closely tied to IP addressing and configuring all that.
Okay.
Right. So, first of all, IP stands for Internet Protocol. I think that's just amazing. Like they just knew they were making the Internet Protocol. There are two versions we're currently using, IPv4 and IPv6. The one, if you're used, if you're used to one of them, it's most likely IPv4. However, IPv4 has a big issue where we just don't have enough addresses. There's just not enough of them. So we needed to come up with a new scheme, a new IP addressing scheme, where like we had a much larger address space, and that is IPv6. And IPv6 also has a bunch of extremely interesting features. I think last year or something like that, 70% of the, or was it 40%, something like a relatively significant percentage of the internet could be accessed via IPv6. But obviously the entirety of the internet can be accessed via IPv4. Problem is we're going to run out of IPv4s pretty soon. And the concept of the IP protocol is that each device has its own unique IP address. But if I tell you the address, if I give you the address 192.168.0.1, does that ring a bell?
What was that one more time?
Hold on, let me. The address 192.168.0.1.
Oh yeah, I see those a lot on
yeah,
routers. At least the
confusing.
first 6 digits.
That rings a bell, right?
Yeah.
Because most likely all
Yeah.
of you have that exact address in your network. So what kind of black magic is that each device is supposed to have its own IP address? And yet, millions of devices, what am I saying? Billions of devices in the world literally have the same IP addresses. Well, that's a technology for another day. That's called NAT, or Network Address Translation. And we will also get to that because this is one of the reasons, NAT is one of the reasons why if you go on Amazon without an account, let's say, or let's say your sister goes on Amazon and starts browsing like dresses, right? And then you go on Amazon, and in your recommendation you see dresses, those kind of dresses that your sister has searched for, but you didn't search for that. Well, NAT is actually why that happens.
Wow.
So that's why my Amazon history is screwed.
That might be why, yes. But Amazon is a little bit more complicated than that in the sense that if you have your own account, that shifts the balance a little bit.
Yeah.
But again, we're going to get to NAT once we have understood a lot more of the concepts. We're not there yet.
Okay.
So, supposedly has its own unique IP address. Now, how do you write an IP address? Well, like I've said, you've probably seen stuff like this, 192.168.10 or 0.1. But you also have the 10.0.1.15, for instance, or 190, and then I used a more random one, which is like 198.122.3.5. Those three addresses have like qualitative differences that I will get into a bit later. Maybe we'll see. But for now, as what you can see is that they're 4 bytes written in decimal and separated by dots, which is a very inefficient way of writing an IP address. Like when you think about it, it's very inefficient. Where it gets interesting though is when we try converting them in binary. And the reason I say that is not to just piss you guys off, it's because we're actually gonna need that. So how do you guys feel about binary conversions in general?
Oh God, I'm getting flashbacks that I need
That's
to study again.
why
I
calculators
used to be able to do it.
What about you, Daniel?
supposedly
Okay.
my Casio can do that, but
Well,
yeah, I think I learned about it on high school or
mm-hmm.
maybe secondary school. So yeah, I think I can do it. Kind
Okay.
of.
Well then, let's go ahead
It's been a hot
and do
minute for
just
me.
that. Like because again, this is gonna be very necessary. So 192.168.0.1, for instance. What would that be in binary? So the 192.168 are the tough ones. How would you guys proceed about like regarding binary conversion, decimal to binary?
It's been a hot minute. Let me go back into it 1 second.
I think that you have to divide over 2, so it's and the so 192 over 2 is 96. You get a 0, so the first number is 0. Then the 96
Nope.
again.
The first number is 1.
1.
So, right. So remember that these are each one
The
byte.
remainder bit.
How
That's
many
right.
bits? How many bits is there in a byte?
How many bits is there in about 8?
8, right. So we have like 8 bits, right? So we need to fill those out.
Mm-hmm.
What's the lowest order bit? The bit on the right. Like how high does it go in decimal?
To 1.
Decimal goes up
To
9.
1. Okay, the second one.
Wait.
To 8.
Second one would go to 2.
No, to 2. Yeah.
Right. And
Sorry.
then third one.
To 4.
And so on. 4, 8, 16, 32, 64, and 128. So the one on the very left is 128, right?
Oh, I was thinking about it incorrectly. That's my bad.
So the way we do it, the way we do binary conversion is we start from like okay, when we do decimal to binary, we start from the very left. We start from the higher order bits. And so the highest order bit right here is 128. Is 128 in decimal? So we ask, does 128 fit in 192? So I'm asking you guys. Yes, it does, right? So the first bit is a 1. And then we need to do the subtraction. So we need to do 192 minus 128. Does that make sense?
Okay, no, I get it. Okay.
Yeah.
Yeah, cause
Right. And that is, I'm just giving you the shortcut, that is 64.
64. Okay.
Okay. What about the second bit?
it'd be 64. It would be subtracting 64.
Yep. So it is
So
a
go to
1.
0.
And then it's 64 minus 64, which is 0. Correct. Which means the other bits are all zeros.
Okay. Gosh.
No, that makes sense.
Okay. Can someone do the second byte? 168. It's the same principle.
Okay, so it would be the first one also 1.
Yes.
Oh no. Okay. And then it would be 0 because
What's 168 minus 128?
yeah, it's 40.
40.
And 40 doesn't fit in 64.
Right? So it doesn't fit in 64, correct?
Then we have to go down to 32-bit.
Yes.
Yeah.
So that's 1. 40 minus 32 is 8. So this was 32, and then it's 16, and then it's 8.
Then 0.
8 minus 8
is 0.
Is 0.
Oh no.
And there we got it. And then it's just 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And there we go. we have converted this IP address into binary. So far, so good?
Yes.
I mean, I'll need to practice it a bit, but yes.
Yes. So I
Exactly.
will, if you guys are interested, I can link you to a binary to decimal practice tool that I've made. It works
Okay.
both ways, binary to decimal and decimal to binary.
It will be lovely.
All right. Let's see.
Yeah, as long as I'm not doing hex conversions, I'm fine.
So
we'll get there eventually.
hexadecimal definitely gets useful later, especially when we start working with IPv6.
Correct. Yeah, because there's I mean, what is it based off 16
Oh
digits?
yeah.
Yes. Well, it's 128 bits. Wait, no, is it? No, it's not. I can't remember exactly the number, but it's an IPv6 address is written usually in hexadecimal.
Okay.
Although in IPv6, it's not as necessary to worry about binary conversions for the most part.
Okay.
So, an IP address, that's cool and all, and that's what you need to... Okay, so when you send a letter, all that you need is the destination, right? You just need to write down the destination where the letter needs to go, and that's it. That's all you need to send the letter. But setting up a PO box takes a lot more than just the address of the PO box, right?
Correct.
This is kind of the same idea for configuration. To configure an IP device, you need to do more than just give it an IP address. You need to give it, at minimum, an IP address and a subnet mask. And if you want it to be able to leave its own subnet, you also need to give it a gateway. Now, I understand that these terms are really strange. They kind of come out of nowhere. You've probably heard of the subnet mask before without knowing what it is.
Correct.
So, to understand what a subnet mask is, we first need to understand what a subnet is. And it's actually relatively simple, but this is where there's sort of a limit to this specific course, because I'm not going to go too much into details into what actually makes a subnet from like a very technical point of view. I'm going to be sort of vague, but if you want to go more into details, I recommend that you check out the more advanced class which is still going to be an introduction, but more advanced class that I'm going to be doing probably sometime later this week.
Okay.
So, what's a subnet? Well, first let's imagine. Does it not let me draw? Okay, fantastic. Oh, is it gonna... I'm just gonna use paint then. It's gonna be a bitch. Okay. So, let's say you have... Can you guys see paint just fine?
Yep.
Yep.
Yeah, I apologize for my terrible mouse drawing skills.
You're good.
So let's say we have two computers directly connected to each other. That would be a subnet because they're directly linked to each other. So far, so good.
Yes.
Now let's assume I have a specific kind of device called a switch. In networking, the icon for a switch is a box with two arrows, or at the very least, just like a rectangle.
Okay.
This right here is equivalent to what I just drew previously. Like these two subnets are equivalent. You could say that in a way, the switch is transparent. So the cool thing about a switch, though, is that it has lots of ports. So I could connect many, many more PCs to this subnet. And this is still a subnet. All of this here, all of these devices, or more, I should be more specific. All of these interfaces, all the network interfaces of those devices, they're all in the same subnet. So far, so good?
Correct. It's kind of like a nervous system with all the extremities and things like that. It's all part of the same subnet.
I'm not sure I'd compare it to a nervous system. I think I would compare it,
I'm just
however,
trying to
to
think of
a.
something centralized.
It's more like it's not necessarily centralized because I could very well have two switches.
Okay, so it's kind of, it doesn't matter whether you have 2 or 1,000 interfaces, they are still connected to the same net, right?
To the same subnet. I'm trying to be very
Subnet.
specific here.
Subnet. Okay.
Right. So essentially a subnet, if I was to be very technical, I would say a subnet is a layer 2 network. But I'm not going to talk here about the OSI model. However, I will in the more advanced class. So for now, I'll just say a subnet is any network that is interconnected through switches, hubs, and bridges. But for the most part, nowadays, we talk about switches. So for instance, your home, technically you have a home network, and that would be a subnet. Where it gets confusing is that a router, I'm going to try to draw this a little bit better. So this is a router. A router is a circle with a circle that is crossed. That is a router. The subnet would include the interface of the router, but the idea of a router is also, it expands here. But the router has more interfaces. That's kind of the point. But the other interfaces of the router are not included in the subnet. In fact, a router is sort of the border between subnets. Does that make sense or not?
No, it does. I'm just wrap
Okay.
my head around it real quick.
Right.
So
Yes, Daniel?
So okay, so you have a router and that
Mhm.
connects to other subnets with other information that you don't have access locally.
So
But the
I'd like,
router,
so Daniel, I can tell that you're really trying to sort of make sense of this as like servers trying to communicate with each other, right? Like, but this isn't necessarily what we're trying to do here. We are like what we're doing here is completely agnostic to what the devices are doing. As in, I don't care like what these PCs are trying to do. These PCs, they might be servers, they might be clients, they might be they could even be like hackers. Like, I don't know what they are, what they do, and I'm agnostic to that. I'm just trying to provide a bridge. I'm just trying to provide network connectivity. I don't know how the information flows, and I don't care. That's not my job here.
Okay.
okay,
But fundamentally, I could have one of these computers be a server and use, that networking that we're putting in place to provide information.
okay,
Okay.
okay.
So a router is the border between subnets. Now, a router can actually interconnect several, like more than 2 subnets. Where it gets confusing, though, as far as you're concerned, is you have an internet box, right? You have something that connects you to your ISP and then to the internet. And where it gets confusing is that I just told you that what you have at home is a switch because you have your own home subnet. But the box you're connecting your computers to is called a router, right? Your internet box, you call it a router.
Correct.
Right.
Yes.
So how is it that a router can also seemingly serve as a switch? Because that's pretty much what seems to be happening, right? Because you have several ports of your router that are in the same subnet, but then others that aren't? How does that make sense? Does my question even make sense to you guys?
Are there multiple systems built into a router, like an interface side and then a switch side, where it's trying to serve dual duties, or is it something else?
That's so this is kind of what happens, yes, but I want to make sure that you're all following me here. Your home router, you're connecting several computers to it, right? And those computers are in the same subnet.
Yes.
But then I just explained to you how a router the interfaces of a router are not in the same subnet. So how does that make sense? Well, the answer is that your router is not actually a router. It's what... Yeah, I know, you've been lied to your whole life. It's actually what we call a layer 3 switch,
Okay.
which is fundamentally a router and a switch put together.
Oh.
Okay, so I was semi-correct then when I was saying it was serving dual purpose. Okay.
You were pretty much correct, yes. Like there's one side of your router, like let's say your home router has like 5 interfaces, 4 of them on one side and 1 of them on the ISP side.
I know there's always like one that's like separate from the others that you actually plug the Ethernet that goes to the cable company with.
Exactly. So the idea is, let's see if I can draw this. Kind of what happens is, so let's say that this is your router. It's just a box, and inside of it, let's say you have like 1, 2, 3, 4 interfaces. And let's make an imaginary switch inside. And those interfaces are all connected to a switch here.
Mhm.
And then on this side, you have an imaginary router that the switch connects to, and then connects to like another physical interface of your router. Does this make more sense when I draw it like that?
Yes.
Right.
Yes.
Now the quick
way
question
more.
is, it was called a level 3 what?
Level 3 switch. Layer 3 switch, more specifically. Again, layer 3 as in reference to the OSI model, which I'm not going to mention here. The layer 3 switch would be like the very technical name. So far, so good?
Okay, so my router is a switch.
A layer 3 switch. Yep.
Yes.
It's the switch, but that also functions as a router.
Right.
But-
It's as in there was kind of a virtual switch inside and a virtual router. Now, I'm putting big fucking quotation mark around virtual here because it's not virtual routing and virtual switching. Like those are very specific things. But you
Okay.
can imagine it as like a box with inside of it a switch and a router.
But they are 2 entities. I mean, in the subnet, they are 2 different entities. One that functions as a switch, another that functions as a router.
Yes, that is correct.
Okay.
In the network. So essentially what happens, and this is maybe where it gets cool, but kind of complicated. You know what? Actually, I'll come back to that after I explain the gateway, which is pretty simple.
Okay.
But, okay, so now we know what a subnet is, right? So, okay, if I was to ask you guys, inside your home router here, where does your home subnet expand? I mean, inside of it, as in like in these components here, like the imaginary components. Where would your home subnet expand to? What interfaces?
That would be like the devices we have around our house, correct? Like phones.
Right.
tablets,
So like you have
computers.
your devices here connected, and then inside of here, where would your home subnet expand to? I mean, in terms of like the virtual. Okay, you know what? To make it more clear, let's go one by one. Is this interface here in your home subnet?
Yes.
Yes.
Yes. Is this interface here in your home subnet?
Yes.
Okay.
Yes.
Is this interface here in your home subnet?
No.
I
don't
know.
know.
I
No,
don't
it's not.
believe so.
It's not. That's another
It
subnet.
ends where the router is.
Okay.
So yes. So your home subnet would expand like so. Does that make sense?
Yes.
Yeah.
All of
Yes.
this, everything inside this pseudo circle, this potato, is your subnet. Is your home subnet.
Okay.
Okay. So is it clear now what a subnet is and how it expands? Like what it covers exactly? Is it really clear?
Yeah.
Yeah, I think so.
Okay. So now we can actually move on to understanding what a subnet mask is and what a gateway is. And you'll see now that we understand what a subnet is, that's going to be relatively easy. So a subnet mask first. Now here on the slide, I've sort of described what it is from a technical perspective, like technically speaking, what it is. Fundamentally, it sort of looks like a weird IP address. It's 4 bytes long, but the difference is, you know, when we did the binary for the IP address, it could be like the IP address was like it was 11000000100101, you know, like zeros and ones kind of spread around however we want. For the mask though, for the subnet mask, it has to be contiguous. It has to be a series of ones followed by a series of 0 and nothing else. That's like how we make a subnet mask, technically speaking. It's a series of it's a series of ones followed by a series of zeros. Although I guess we'll come back to that after, because what's really important with the subnet mask is understanding what purpose it serves. So the point of a subnet mask, and I'm going to make an analogy with the like regular post office addressing. The point of a subnet mask is to determine what part of your IP address is your network address or network prefix, and what part of the IP address is like the device address. So let me make an analogy. When you send a letter, let's say you send a letter 256 Programmer Street, right? That's the full address. If I work for the post office and I'm going to try to deliver that envelope, first, I'm going to look for Programmer Street, right? I'm going to look for the general area. So I'm going to first look for Programmer Street. And then once I found Programmer Street, I'm going to look for the number 256 on Programmer Street. Does that make sense?
Yes.
Okay.
Okay.
So you can think of a subnet. You can think of a subnet as a street. Fundamentally, the subnet is the general area where we're trying to deliver not letters, but packets, IP packets. So in an IP address, there is one part of the address, one half. It's not exactly a half, actually. It doesn't have to be half of the address, but there is one part of the address that describes the general area, and there is the other part of the address that describes the specific device to which it's supposed to be delivered. So for instance, and so the street, the equivalent to the street name would be what we call the network prefix, sometimes called network address. You know, for all intents and purposes, it's the network prefix that works for us. So for instance, if I was to give, so each subnet has its own network prefix. Does that make sense? Each subnet has its own network prefix. For instance, this subnet has network prefix would be 192.168.1.0, and I'm going to say /24, and I will explain what the /24 means. Well, /24 means that the first 3 bytes are part, like, describe the actual prefix. So, okay, that was a lot to take in at once. Let me try to, okay, you know what we're going to do? We're going to do this the other way around. Daniel, I want you to try and explain back to me what I just told you. This is not a test, by the way. I want to know, like, what's not clear.
Okay. So we have a weird IP address
Yes.
that functions as a way to indicate the zone, the general zone, the big zone
Correct.
in which our subnet is in.
So it's not exactly that.
No?
It's more
Okay.
like the subnet is the general zone.
Oh, okay.
Right.
Okay.
So this weird looking address here, that I call the either, I'm going to write that down. The network prefix, or sometimes network address. This IP address here is the address of the subnet. This is as if I was saying just programmer street without a number.
Oh, got it.
Okay. And then inside that subnet, I can say, okay, here's PC number 1, here's PC number 2, PC number 3, number 4, and so on.
So the network prefix is like the street,
Yes.
and then each of the individual each of the individual addressed devices are basically like a house on that street.
Exactly. That is precisely the analogy I'm trying to make. This is exactly
Okay.
that. Yes.
Okay, nice.
And also it sort of makes sense when we will talk about routing, but it's like we go from one subnet to the other, as in we go from one street to the other, right? To finally get to our destination. But this is a bit more complex. We'll get to that later.
But just to verify, the network prefix is the street, and the network address is the individual units, right?
What's
Or
that?
Did I see that?
Network prefix and network address are basically the same thing. They mean the same
Okay.
thing.
But that would be like the street, and then what would you call each of the actual devices within the subnet?
Terminals.
Terminals? Okay.
Because they terminate the network, right? They only have one
sense.
network interface, so they are
Sounds so
terminals.
logical. It makes so much sense. So many names now.
I know, right? It's like all of those things you wish you could understand, but it's actually fairly straightforward once you understand the general concept.
Yeah.
And it's not that, like, it's fairly straightforward, yeah. So, for instance, if I was now to give an IP address to PC number 1, what IP address would I give it? Can you guys give me an idea?
100.
Would it be
Well, the
would it be
prefix.
192.168.1.0/1?
No, I think they would.
No.
Maybe
So,
wrong.
okay,
One.
I'll get to the
1.1.
slash afterwards. Actually, it's going to be 0.1/24.
Okay.
I'll explain
got
when the 24 means, like, actually just right now. So the /24 is just another way of writing the network mask. So now that we understand the general like idea of like giving a subnet its own address, so like the network prefix or network address. Now that we understand that, let's go back to our slide and let's read this. So a network mask, the point of a network mask is to determine, so because we only have one IP address, but in that whole IP address, there are actually two parts. One part that describes the network address, one part that describes the device address. So we need something to know like where the network address stops and where the device address begins, right? We need some way to know where that divide is, where that dividing line is. Does that make sense?
Okay.
Yep.
Okay. So I've given you an example of a network mask here. 255.255.255.0. That means the first 3 bytes are for the network address, and the last byte is for the device address. Does that make sense?
Okay.
Right.
Yeah.
So that would mean, for instance, in our example, if the network mask here is 255.255.255.0, which it is, if this is our network mask, that would mean that any address that begins with 192.168.1.0, or actually that just begins with 192.168.1, any address that begins with that, any IP address that begins with that is within this subnet, is somewhere around here. This means we are on Programmer Street.
Okay.
Right.
Mhm.
Now, Can one of you try to guess what the... So I've told you the /24 is also the mask.
Okay.
Can one of you try to guess, like, okay, so 255, 255, 255, 0 is equivalent to to just writing /24. So if you see slash something, the second value after the slash is the subnet mask.
Okay.
Always. Can one of you try to guess what the correlation between 255, 255, 255, 0 and 24 is? What's the correlation there?
I know a lot of early machines couldn't count up to 256, but I don't think that's...
No, that's not it.
I know. I'm just trying to think through it.
Both kind of are powers of 2, but 24 is also multiplied by 3.
What'd you say about 24?
So it's weird.
It's 8 times 3.
Yeah, but
Okay, that's good. That's good. That's okay. 8 times 3. Follow that one.
okay, and 8 is 2 to the power of 3.
Right, but
There.
how many?
Oh wait, I'm thinking. One second.
How many bits do you have in a byte?
8.
8. Oh my
Okay.
god. Yeah.
You see it?
Okay. Yeah, I see it now. So
Yeah,
that
it's...
if you divide by 8, I mean, okay, so if you divide by 8, now you have the amount of things of numbers. Yeah, of numbers.
Of binary ones.
Yeah.
Right.
Okay.
Right. You found it. So the idea is, let's reread.
Wait, I might have missed it slightly.
Don't worry, we're gonna go over it. So let's have another look at the slide. So I told you that a subnet mask is always a series of 1s, followed by always a series of 0s. All right, it's always a big block of 1s and a big block of 0s. And I'm talking binary here. So if I was to write 255, 255, 255, 0 in binary, what would that be? Let's do this one. So let's see. 255, 255, 255, 0 in binary. What's that?
That'll be all 1s, correct?
Yes. Well,
8
all
ones.
1s until
Well, yeah, until the end.
the last byte. Yes. How many 1s is that?
8.
So let's see. Let's count. So we have 1, 2,
4,
3,
8,
4,
12,
5,
16,
6,
20,
7,
24.
8.
It's 24.
It's 24 1s. Ding, 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 ding.
24 1s and 8 zeros.
Exactly. So /24 means we have 24 1s. That's our mask. It's 24 1s.
Oh my god.
I know, right?
And we
Makes
can
so
and we
much
can afford
sense.
to do that. We don't have to write the full thing because we know it's always going to be a series of 1s followed by a series of 0s.
I think that's what I was like mistakenly like referring to earlier with the whole 256 a lot of machines because it's an overflow back to 0. I know. I'm just saying like that was some of the reason why I had confusion earlier with the...
There's no real question of overflow here. Because we're not programming values in the computer. That's
Correct.
not exactly what we're doing. Anyway,
We're just stating the theoretical maximum of this address.
kind of, not really. It's not exactly that. But the point is, now we have a very neat way of writing a subnet mask. So in our example, I said the network prefix is 192.168.10/24. What that means is that the 24 first bits of this address represent GNS3. So I am aware of GNS3. It's fantastic software. It means that the first 3 bytes, the first 24 bits, so the first 3 bytes of this address represent the subnet address. Okay? And so if I go on this PC and I say, hey, your IP address is 192.168.1.1, and your subnet mask is 255.255.255.0, which is equivalent to /24, I'm basically telling it, you belong to the subnet of which the subnet address is 192.168.1.0, and your device address is just 1. Does this all make sense?
Yes.
Okay.
Okay. So with that, we technically already have some form of network connectivity. I can go around and tell all the computers, okay, you are 192.168.1.2/24 or 3 or whatever. You are 192.168.1.4/24. Now be aware that if you don't, so what this also means is that all the computers, all the terminals, or the more specifically, all the interfaces in the same subnet must have the same mask, and they must have the same network address. What about /32? /32 would be a loopback address. /32 is a thing, but it's basically when you have, let's see. So I'll take the example on the router. /32 would be you have an interface pointing to its own self, and it's usually, this is the icon. It's an arrow pointing back to itself. That would be a /32, which means there is only one address possible in that subnet. It's kind of strange. I don't necessarily want to get into that too much into details. And this would usually be used. This has many uses. It's just like it's just a handy feature to have around usually. Okay, loopback address. Yes, your PC has a loopback address. You know so just to answer Wolf in chat, you know the 127.0.0.1 on your PC? That's a loopback address. That's an address that lets your computer connect to itself.
Okay, that makes so much sense. That's why you can download your own mini server for example, MAMP or XAMPP, and run, because the client and the server are the same machine, because the IP address is a loopback address.
Exactly. 127.0.0.1 is your loopback address. And localhost, the word localhost is just like, it's your domain name that points to the IP address 127.0.0.1. So those are equivalent. 127.0.0.1 and localhost are equivalent. They're the same thing.
Wow.
Okay,
Well,
gotcha.
if you're studying for a CCNP, we can have a bit of a conversation about this a bit later. This is more of an introduction course, but I'm glad you're here. No worries. All right. So where was I?
Loopback address, subnet mask.
So I was talking about the subnet mask. So is it clear what a subnet mask is and what it does, how a
Correct.
subnet expands? Right. So all of this is really important, right? This is like the foundation of how we're going to be able to just like get IP connectivity altogether. You're not going to be able to get any IP connectivity if you don't know what a subnet mask is.
Okay.
All right.
Okay.
I suggest we take a short break now to try and digest all this, and I'll answer some questions in chat. And during this break, we're going to take like maybe 10 minutes, 10, 15 minutes, more like 10, I'm hoping. And during this break, I'm also going to link you Cisco certs. I have let's see, I have, so I was, okay, I'll answer that in a question. So during the break, I'd like you guys to install a software called Cisco Packet Tracer, which is going to be just terrific. It's going to be extremely useful for what we're going to do. Crap. Okay, hold on. Give me a sec. I'm going to link it to you real quick. Basically, it's a network simulator, not an emulator, not a virtualizer. It's a simulator, but
Okay.
it's going to allow us to sort of play around with IP addressing, see what works, see what doesn't. Like, what if I put a router there? What if I configure it like that? And for all intents and purposes, this is gonna be this is gonna be more than enough for what we're gonna be doing here. There's one detail though. When you install it, like finding the download link can be a pain because you have to create an account and like apply for a weird ass course on the Cisco website and all of that. Instead, I'm just gonna give you the installer, but you're gonna have to create a Cisco account if you want to save what you make. But otherwise, you can log in as guest. You're not gonna be able to save, but you can still use the thing to play around.
Okay.
Okay. So you guys
actually
need.
do
Yes, you have a
one
question?
quick question.
Yes.
This might sound extremely dumb, but what happens if you have more devices on a local network? Does then it go to a different?
If I have what?
Because we've been doing everything based off the /24, and if we address everything from 1 to 24, what happens if we go over 24?
It won't work.
What do you mean? Like, if instead of /24 we had
devices.
/28, for instance?
Well, I just meant if, say, like the subnet, if on the subnet it's /24 and you have, say, 25 devices on the network.
That's not how it works. Okay, so what does the /24 do?
It basically just tells you where each device is on the subnet.
Not quite. Daniel, can you help us out?
Okay, so the mask, there are two parts of the IP address.
Yes.
One is the prefix, and the other one is the position of the thing, the terminal. Yeah.
Okay.
So, the mask in this case is 192.168.1, and then the
No,
zero.
that's not the mask. The mask would be
No?
255, 255, 255.0, or /24.
Oh, yeah.
That's
Yeah,
the
yeah,
mask.
sorry.
Be careful.
That's the mask.
Yes.
And then it indicates that the first three numbers are the prefix, right?
Yes. The
That's the
network prefix.
function.
Yes.
That's the function of the mask. And then the zero, the last zero, can be used to indicate each terminal, right? So, for example, my computer would be 192.168.1.1
Yes.
/24, and the 24 is used to say, okay, the first three numbers are the prefix, but the fourth number is not the prefix, is the number of the machine.
Yes.
Right?
Yes.
So you can theoretically have 1,000, 10,000 machines in that last number.
Actually, you can have up to 254 devices in that server in that subnet. Up to 254. Okay. That's something I didn't necessarily want to touch on here.
Okay.
But this is a little bit more like math oriented. But again, this is where binary sort of helps us a lot. So
okay.
I guess we can do that real quick before taking our break. So the idea of the mask is to describe how many bits of the address determine the network address and how many bits of the address determine the device address. IPv6, oh no. I love IPv6 though. I think it's super cool. So basically what this means, if my mask is /24, this means that I can have as many devices in one subnet as I can fit addresses in 8 bits, the 8 remaining bits that aren't used by the prefix. Does that make sense, Scout?
No, that does.
Okay. So how many addresses can I fit in 8 bits?
254.
So it's actually 256,
No,
but
200
we removed
yeah,
two of them.
zero.
The top one, where all bits are 1, and the bottom one, where all bits are zeros, are sort of reserved. I'm not
Okay.
necessarily going to go into details as to what they do, but they're reserved. So to know how, that's actually a cool thing you can do. So you can calculate how many, you can know how many devices you can have in one subnet just based on the mask. So if I have a /24, my IP address is 32 bits. 24 of those are used for the prefix, meaning I have 32 minus 24. I have 8 bits left for device addressing. So, okay, hold on. This will be more clear if I do this. So I have an IP address. This is very this is impractical. Okay, IP address 32 bits. If I have a /24, it means I only have 8. So I have 32 minus 24 equals 8 bits for device addressing. All right. And then I can fit however many devices in that subnet as I can fit addresses in 8 bits. So that would be 2 to the 8, which would be 256,
Just with
of
two-
which
two
2 are reserved.
Okay.
Always exactly 2.
Only 2 there are. I'm
Right.
I'm not gonna make the Star Wars joke. Never mind.
By the way, that also, I don't have, like, it doesn't, the mask doesn't have to cut exactly on a byte. So I could have, for instance, a /30. /30 means 32 minus 30 equals 2 bits for device addressing, which means 2 to the 2, that's 4, of which 2 are reserved.
Okay.
Which means I only have 2 usable addresses.
Got it. Okay.
Does that make sense for everyone now?
That does.
Okay.
Yeah.
So, what we're gonna do is we're just sort of gonna play around with, you know, terminals, switches, routers, and sort of see what happens. So, on the lower left corner, you'll see a bunch of icons for different kinds of devices. So, for instance, you have network devices, end devices, components, connections. What we're gonna be using first. So end devices are terminals. So you have PC, laptop, server. Those are basically the same thing. Like, for all intents and purposes, they're the same thing. So we're just
Okay.
going to use a PC, for instance. So we're going to use, let's say, 3 PCs. You just drag them, and you have them on the thing. And then we said
Alright.
that to make a subnet, we need a switch. So let's go
Where are
over
those?
to
I'm looking.
network. Is it network devices? No, those are routers. Switches, there you go. Oh, I see. Okay. So if we go to the network devices tab, and then underneath that, there's a switches tab. So we can use for instance, the first one, the 2960. And then we go over to connections. There is like the little lightning thing is the auto connection, so we don't have to worry about what's being connected how. It's just gonna detect automatically. We need to wait about 15. Wait, how long is it again? Is it 15? Can't remember.
Yeah, 15 to 30 depends.
How do I get rid of something? Do I just hit delete on it? Yeah.
Right now, you can also left click on the PCs themselves and go on the desktop tab. And here, for instance, you can configure the IP address. And you can also have a command prompt, which you can use to, for instance, attempt a ping. Let's try to ping something.
And
Like ping
which
192.
connection did you go with? USB?
I use the
Copper
auto connect. So like the little lightning thing, which is the
I
auto
see it.
connect.
Got it.
Okay. So if I try to ping, it's obviously not going to work.
And what do we need? That's the question.
Well, we need all the devices to be properly configured, right?
Yes.
We've learned how to configure a subnet, the IP devices in a subnet. So let's go ahead and do that. We need to configure their IP address and their network mask, their subnet mask. And there under the desktop tab, there is an icon here for IP configuration. And here we can see either static, which is what we're doing. We're manually filling those fields out, or DHCP, which we will go over in a future lesson. So once you're here, you have to remember all the devices in the same subnet must have the same mask, the same subnet mask, and share the same network prefix. So what we can start by doing is actually deciding on a network prefix, right? So what I'm going to do is I'm going to add a, where is it? A note, I guess that works, and say this is the network 192.168.10/24. I'm not sure if you guys can see it. Okay, maybe. So this is the subnet 192.168.10/24, which means when I configure my PC's IP addresses, they must all begin with 192.168.1, and they must all have a mask of 255, 255, 255.0. For instance, here PC2 now on the desktop, 192.168.1. 2 with a network mask of 255, 255, 255.0, and PC1.
Oh, I got it. And how do you have it set up where it actually shows what yours is? Because mine only shows when I click on each one.
I'm not sure. What do you mean?
Like I have to manually click on each one to show what the actual
Oh, it's because I added a label manually. Like this, the fourth icon.
Oh,
here,
got it.
I added a
I
note.
I see
right?
it. I see it.
Yeah, I wish it was automatic. Maybe there might be an option. I'm not sure.
Oh, you're good.
All right. So now that I've configured all of my IP addresses, let's see if I can actually ping. So pinging is the ultimate test for IP connectivity. If the ping passes, then I've got IP connectivity. So let's go ahead on a command prompt and let's try to ping 192.168.1.1, for instance, from PC1, which is 192.168.1.3. And see, I'm getting replies. That means it does work. I do have IP connectivity. Hooray!
Nice.
Go ping.
You just write ping and the IP address?
Yes.
Nice.
So we've got IP connectivity. Now, we have a subnet, and that's nice and all, but we'd like to go beyond our subnet, right? Like when you try to go on the internet, you need to leave your home network. So how do you think that works?
With a router?
Exactly.
It's sending your router out to your ISP's subnet.
Yep, basically. So this is where this is where we're going to use we're going to configure our router, or more precisely, we're going to configure a gateway. So let me see. Let me bring this back up. So we've seen the subnet. So
IP.
now we're going to focus a little bit on the router. So like I've explained, the router is both a border and a gateway that separates and interconnects different subnets. So like for instance, between your home network and your ISP. By design, and this is kind of weird, but by design, all of the interfaces of a router must, not just can, must be in different subnets. In practice, it's a little bit more complicated.
Okay.
So what that means is, let's say I'm gonna take, again, from network devices, I'm gonna take a, let's see, what am I gonna take? 1941, for instance, a router. I'm going to interconnect it with my switch. And I'm then going to set up another PC and connect it to the router. Now, one thing about the Cisco routers is you must manually turn on the interfaces. It's network interfaces. However, I can't remember if there's... I hope I don't have to go and see like CLI. Okay. So when you've placed the router, under config, you can see the two interfaces of the router. There's a gigabit Ethernet 00 and a gigabit Ethernet 01. You need to turn those on by clicking on the checkbox next to port status. And that will turn on the interfaces. And under the same tab, you can also configure their IP addresses. And the first thing you see that I sort of implied but never explicitly said, each interface has its own IP address. Meaning if I have a device with several interfaces, that device will effectively have several different IP addresses. And that makes sense because each interface will be in a different subnet, so each interface must have a different IP address. That makes sense, right?
Okay.
Mm-hmm.
So we want one of the interfaces to be so for this router, one of the interfaces is inside our home subnet, let's say, and the other one is in, let's say this is our ISP subnet. So here I just created a new subnet, so I must give it a new network address as well. So I'm going to do just that. I'm going to declare this is network 192.168.20/24.
Okay.
So it's not the same because it's 20 instead of being 10. It's not the same network address, meaning it's a different street. It's a different subnet. And then I need to go ahead and manually configure the PC that's in that subnet. So under desktop, IP config 192.168.2. Let's say 100.
Mine's saying invalid on mine.
Let me check this out.
Did I not set my router up correctly? I turned the port status on, and now I'm setting up the.
Okay.
Let me look.
Yeah, let us have a look.
A little bit unsharp. I can barely read it.
Yeah.
Oh, let me see if I can.
Oh, because you've okay. I know why. I know what you did. So you tried to set the IP address to 192.168.20.
Yeah, that doesn't work.
Yeah. So remember that the very first IP address, so the lowest in a subnet, and the highest in a subnet are reserved. You cannot use them. So in our case, 192.168.20 and 192.168.255. Those two addresses you cannot use to use in your configurations.
Okay.
So it has to be 1 or 2 or 100.
253 or 254.
Or 254, up to 254. Yes. Okay.
That's great. Yeah.
Okay.
And now you also need to configure the IP addresses for the router itself. So this is where it gets a little bit tricky, and this is where Cisco Packet Tracer starts being annoying, because I need to know which one of the interfaces is in which subnet. So the way I'll do that is I'll hover over the little green arrow next to the router. And for instance, I know that the interface that is in my subnet to the left is interface gigabit 01. So gigabit 01 is in the subnet number 2 on the left.
There's actually an option for that in Packet Tracer to enable that by default.
Oh yeah, you're right, there is.
But maybe for later.
Yeah. So I'm gonna take gigabit 01, and because I know it is in this subnet on the left, I'm gonna give it 192.168.2, and then I'm gonna give it 1. with a default mask of 255, 255, 255.0 or /24. And then the other interface, the 00, is obviously in the other subnet. So I need to give it a proper IP address as well. 192.168.1. I'm going to give it 1... This is where it gets weird. I'm going to give it 1.1. Now, one issue that I have is that right now I have 2 computers with the same IP address, but I want the router to have the sort of lowest available IP address. So one of my PCs is configured with 0.1, and I want to change that. Wait, is this one not configured? Oh yeah, okay, it was unconfigured. So 192.168.1.4.
I mean, it really depends. Like, is it generally the highest or the lowest number?
Yeah, it's usually the lowest though. I've
Yep.
basically never seen highest being used for a gateway.
Actually, on my home router, it's the highest number for some reason by
Really?
default. Yeah.
Like I said, I've never seen that in practice.
Makes sense, but it happens.
I think it's because 0.1 is just easier.
Yeah, it's easy to remember.
Yeah, but especially like the highest value is fine if your mask is /24, but if you have like a, I don't know, like a /20, that gets difficult. Although
Yeah,
who the fuck uses /20? Well, if you were conscientious about your IP address, I'll say this regarding IP coverage, and this is a quick tangent, but like essentially the IP addressing space is very limited, even for like private use. And I've definitely seen companies being like, oh yeah, we have more than enough IP addresses for everything, and just using /24s where maybe a /28 would have been enough. Basically wasting a lot of IP addresses of their IP addressing space. And it's such a mess now that I'm not going to name the company, but it's such a mess now that they have to internally use mechanisms like NAT that I've mentioned before. They have to internally use mechanisms that they most definitely shouldn't to just make it so that it just works. And it's a real mess, and it's extra work just because people were careless about how they use their IP addressing space.
The internet's not going to become a commodity. We got this. We have enough.
Yeah, but like if you unless you've got literally thousands and thousands of terminals, you're probably okay. Okay, so is everyone done configuring the router?
Correct.
Yeah.
Done it yet, but I will come to it.
So I finished configuring the router's IP addresses. So what I'm gonna do, I'm gonna take a PC, I'm gonna go under command prompt, and I'm gonna try just pinging the router itself. I'm not gonna try to go past it. I'm gonna try to just ping the router. So I'm gonna do again ping 192.168.1.1. That's the IP address of the router in my subnet, and it works like you would expect. At the end of the day, it's just another interface connected to our subnet. Now, what do you guys think will happen if I try to ping the PC in the other subnet?
Oh,
Place your bets, ladies and gentlemen.
It doesn't work.
Can I bet what happens? I will let them go first.
So what do you think happens? Does it work? Does it not work? Who thinks it doesn't work?
Me, I don't think it works.
I do, because I tried it.
Daniel, you think it will work?
It won't work.
It will not work? Okay. What about you, Scout?
I think it will.
This is
I
fun.
think we can-
All right. Let's
I
see.
pinged my first one properly, but as for the second one, I'd see.
It doesn't work.
Ah, damn.
Now, here's why. So, essentially what I'm doing here, what I'm telling this PC0 here on the bottom left, when I'm telling it, hey, go ping address 192.168 to 100. the first thing the PC will do, this PC, the first thing it will do before sending anything is it will check, hey, do I know who that is? For instance, is it on my street? Well, the answer, so it will check if, it will check against its own IP configuration and see, is it in the same subnet as me? Now, it does that check every single time it tries to send a packet. When we sent a packet to 192.168.1.1, the answer to that question was yes, we were in the same subnet. But now we're trying to go in a different subnet. We're trying to go in subnet 192.168.2. And this is where the knowledge sort of becomes much more limited. Like our PC is like, okay, this is not on my street, and I have no idea how to get to that street. So I'm just not going to send anything.
Okay.
So we're stuck. Essentially, we need a pointer. We need to have a direction of where I need to go next. And this is where we're going to configure the default gateway. The default gateway is the IP address of the interface that I need to sort of pass my packets to if I want to leave my subnet. So essentially, if I need to send a packet outside of my subnet, who should I ask to handle that packet? Can you take a guess what that should be?
The router?
Exactly. It should be the router. So 192.168.1.1. That's actually the right answer. So is it gonna work now? Is the ping gonna work? Now I'm gonna try to leave my subnet again. Is the ping going to work? Yes or no?
Yes.
Yes, it's going to work.
What do you think, Wolf?
Did you configure it on both computers?
I didn't.
Then it won't work.
Oh,
It's not gonna work. Exactly. Because a ping is a round trip. A ping is always a round trip. So here what's happening is that the ping most likely finds its way to PC3, but then PC3 is like, okay, I need to send the sort of the receipt back to the sender. Okay, what's the IP address of the sender? Because
I have
that's
no
included in the
idea.
IP packet. Okay, the IP address of the sender is 192.168.1.4. And then it does the exact same process, and it's like, okay, that's in a different subnet. And it doesn't know how to leave its own subnet. So it's stuck. So what we need to do is configure the gateway on PC3 as well. So again, IP configuration, the gateway, and this time the gateway is still the router, but it's the other interface of the router, is the interface that's in its own subnet, right? So 192.168.2.1. Now, is it gonna work? Is the ping going to work now?
now since it has both directions, then yes, it should.
And it does.
Lovely.
Now all that's left to do is finish configuring all PCs with gateways. So 192.168.1.1. And this one as well. 192.168.1.1. And there we go. We have now two subnets interconnected via a router capable of pinging each other. Now we can do the test if you want, right? Let's go on a different PC, command prompt, ping 192.168.2.100. It does work.
Could you do the command trace route?
I didn't do trace route, but we can do a trace route. It's so in that would be trace RT 192.168.2.100. So a trace route, for those of you who don't know, a trace route is basically trying to determine the path It's not just trying to determine, like, it's not just, hey, do we have connectivity? It's, do we have connectivity, and how do I reach you? What are the different hops? And here, for instance, we see one hop is going to be the router, 192.168.1.1, and then the next hop is going to be directly the final destination. So essentially, it gives me a route of all the routers I have been through.
Okay, so it's like turn-by-turn navigation. If you printed it out, it's showing where you made all your turns.
Exactly. And you can use traceroute on your own PC right now. So if you were, for instance, to open a command prompt, now I don't want to dox myself, so I'm not going to run it, but you can do trace RT, and for instance, 8888, which is the Google DNS server, you can go trace RT to 8888, and you would be able to see, not all, but most of the routers that you're going through. The reason you don't see them all is because some routers are configured to like not reply to trace RT requests.
Okay.
Fundamentally. The way trace RT work is really interesting, but I don't think I want to get into that. So you go ahead, try trace RT 8888 on your actual Windows machine right now, or Linux if you're on Linux. Try running it, see what happens, and it might take a little bit, but you'll see you're gonna have a bunch. You're gonna have a bunch of jumps. You're gonna see all the actual routers of the real world that your packet has gone through to reach that server. So in summary, we have our IP address, we have our subnet mask, we have our gateway, and remember that the lowest and highest addresses of each subnet can't be used to actually configure a device, like they're reserved, right? Remember that. And what I'd like you to do for next time, or maybe right now, like up to you, but I'm gonna cut the stream. What I'd like you to do is tell me whether or not, so I have several pairs of addresses here. I'd like you to tell me if they're in the same subnet. And or like, so in the same subnet. Yeah, I'd like you to tell me if they're in the same subnet. If you play around with Packet Tracer, you also have a mode down on the bottom right called simulation mode. And essentially you can see the packets actually being transmitted. So let's say I start simulation mode. I open up a PC. I want to send a ping. I will see the actual pings being sent one at a time. Now I need to edit filters because I don't necessarily want to see all the protocols. The only protocol I'm really interested in is ICMP. ICMP is the ping protocol. So I'm going to uncheck everything else. I only want to see ICMP. And so here's the ICMP packet being sent. Okay. So
Wait, how do we switch to simulation mode?
Simulation mode is on the bottom right. You have real time and you have simulation.
Oh, I see it.
And the ping is being sent to PC3, and then PC3 sends the reply. Goes through the switch to the PC. Wait, what was that? Was it not? Oh yeah, because it's sending it's sending 4 pings at a time. So if I go back on PC, yep, it's received 1 ping, 1 reply. And now, boom, it's received the second one.